isn't it just about writing software and just, in school projects, you typically write some piece of program and then you compile it and build it and you just run the program, right? So what's the software delivery model in this context is what we want to talk about today. Before that, I do want to let you know that if you have any questions whatsoever, you can post in chat window and so on. Ganpat and person who has joined as the Satcom Foundation, is there any other guideline that needs to be followed? Okay, so let's keep moving. I presume there are no major comments on that. So if there are any questions whatsoever, please do keep sharing here. Okay, so going back to a delivery model, what does a software delivery model really mean, right? Anyone wants to take some guesses on what a delivery model really means when we talk in the context of software delivery models? Any guess? Anyone wants to attempt any? You can write your comments to here. Okay, I guess there are no major comments. So let's get started. So what does software delivery model mean? Is that unlike what you have, go ahead, Hemant. Let me see your question here. Hemant, you had raised your hand. Do you have a question? Okay, I guess let's keep moving. So, unlike your school projects, one of the biggest things in the real world when you are developing large software that needs to be used by hundreds or thousands or millions of users, right? The project then, the software itself is a very complex piece of software. It's not like a very simple, program that is just doing a sorting of a file or reading and writing of a file, like what you have typically done in school projects and so on. It is much, much more complex. There are thousands or millions of lines of code that need to work, execute together, and produce meaningful workflows or meaningful results or meaningful computations and so on and so forth, right? And when a large group of software engineers are working together to produce one large piece of software, you are going to be running into greater challenges. So there is this typical adage that smaller teams can actually run faster than the larger teams, right? In software. So what it means is that as more and more people are developing software towards a common cause, it is possible that there is going to be more challenges that come in. How do they develop software such that it's all coordinated and gets to the end user in a structured way, in a way which is of acceptable quality, and in a way which is of predictable way, in which they know that, okay, I have my version 1.0 of the software that is going to be available on March 17th or something like that, right? Because the company that is selling the software has promised to its customers that I'm going to give you the next version of the software on this date. So you're going to be able to do this meeting of the deadline with the large team that you have. Meanwhile, you have some teams which will also, let's say that they think that this software, this whole functionality or this product or feature or whatever you want to call is going to take 6 months. Meanwhile, There are people who will be taking vacation, maybe people who will be leaving the company, there may be new people who are joining the company, new projects, and so on and so forth. But you still have the commitment to make sure that you are meeting that deadline and releasing the software in a predictable way as you have promised your customers and your stakeholders and so on, right? So this delivery model then starts coming into picture, right? Because it's not one person alone who's developing software. It is multiple people coming together and developing and pushing the software to customers. You need to define some kind of a process. You need to define some kind of a delivery model in how these teams are going to be working with one another. You need to come up with ways by which you handle exceptions, or when there is a change in the workforce or things like that, how do you deal with it, and so on and so forth. So you need to put some kind of guidelines such that you are able to release quality software with a large number of software engineers and deliver it on time, the right quality, right? And it can be done in multiple ways. And that is what we are going to be talking about as software delivery models. The multiple ways by which you can actually accomplish the act of delivering good quality software in a predictable manner is what software delivery model is, right? In a way, you are in an individual school projects and so on, where you are just doing your own school project. It's possible that your professor has given a deadline, and you say that, hey, the deadline for that submission of the project is this particular date, and you know that if you don't meet that date, you're not going to get your grades, right? So you work backward from it. You say that, okay, 18th of March is the deadline. I know that this is going to take me at least 7 or 8 days. I need to give some buffer of, like, in case there are some questions, challenges, and so on, or if there is some problems, I need to worry about how do I understand what the professors ask of the uh, assignment is or the project is and clarify. So it gives some time. So you need to work backwards so that you are able to predictably deliver your assignment, even in an individual manner. And in a way, so what you have done is you have set yourself up for a delivery model in how in a manner by which you are able to predictably deliver on your assignments to your coursework, to your professors, and so on and so forth, right? And the same thing happens in companies. It's just that it is different methodologies and so on and so forth. So let's go to the next slide. So we're going to talk about, so in a way, we have already talked about concepts. What are the different types of software delivery models and the techniques, and some case studies associated with it, and summary. So what are the main concepts when people talk about software delivery model? The first concept that you will keep hearing is the fact that, the product and the software that you are delivering is of acceptable quality, which means that it needs to be a product which is free of defects and issues, that when you actually give the software to your customers who are going to use the software, they are not running into bugs that are completely broken, bugs that are actually going to cause issues by which they cannot accomplish the task for which they paid the money for the software for, and so on, or like they are using it for healthcare and finance and things like that, in which case it's even more critical that there are no major bugs that are in the software product that you are giving. Yes, Vinita, go ahead. You have a question? I see that a person called Vinita has raised their hand, checking if there is a question. Okay, I presume it's not there anymore. Are you guys able to see this? What is being presented in the screen? I just want to make sure that you are able to see what is being presented. Are you guys able to see the screen? Yes. Okay. Thank you. Okay. So we did. So I'll go back. We were talking about quality of the product that you're delivering. Second is the velocity. Velocity is the speed at which we can deliver, right? Um, it's how fast can you deliver, right? Given a specific duration, how much software that is of acceptable quality, that and it is meeting the requirements for solving that problem that has been asked to, is actually being produced in that duration. That's the velocity, how much software you are producing, or how much of the product that you are producing that is going to get. The third is the predictability part of it, right? Predictability part is when you said that you will deliver this particular product on this date, are you being predictable? And that you have factored in all the things that can go wrong. You have planned for it. You have also planned for contingencies. You have planned for the fact that there may be some unknowns that you discover only when you are developing the software. You go there and then you find that, oh, this particular technology is not sufficient for me. I need to move to different version or different technology and so on. So, but you have thought through all the steps that are there, right? Remember, unlike the uh, product where it is like a car assembly, right? Like where significant things are touch and feel. While in the case of software, it is most of it you are either writing it or you are visualizing it before it is actually developed or before you are specifying what needs to be developed, right? So it is going to be a challenge. So you just need to make sure that you are spending enough time thinking through all the complexities of how software is to be done before it actually goes. That's one. The last part is the part of a business model, right? How is the software itself going to be given, right? Is it sold as a business to business? That is, a software development business is selling the software to some other business which is using it for running their workflow. Like, for example, a company like, say, a Salesforce or Microsoft Office, and so on and so forth, right? They are developing software which is used by other businesses to run their business, right? So that's the B2B model, and versus a B2C model where you're developing software, where the software is directly used by the customers themselves and not through some other business itself. Like, for example, um, let's take an example of Google or Facebook/Meta, right? They have developed a software, they put it out there, and we are all as customers using the Google search or Instagram or WhatsApp and so on and so forth. And these are all B2C types of softwares versus the B2B, where the business developing the software is giving it to another business and not necessarily end customers to use it left, right, and center. Any questions? Okay, let's move to the next slide. Are you guys able to let me just see why this? Okay, so what are the different types of these software delivery or software development lifecycle models, or SDLC as is, right? There are models which have evolved over time, right? And then there are models which uh, were defined right in the beginnings of, like, say, software engineering as a discipline itself has been around since, say, 1950s and 1960s, where we saw that a large number of software developers are coming together to build a large software product and so on. So there was some kind of an engineering discipline that needs to be shown to them, similar to how you actually have some kind of a process associated with, like, say, building bridges or laying electrical wires and so on and so forth, right? So the software engineering discipline in the 1950s and 60s, the people who were practicing it thought that, let's put some specifications around it, right? So they came up with formal specifications. So you will hear terminologies like waterfall, or it's an iterative and incremental process, or it's a Scrum, or extreme programming, or it's Kanban, and so on. So what you see is that there was these formal methodologies, which were like the waterfall and V model methodologies, which are much earlier, and which are much more sequential, where, like, you do step one, followed by step two, followed by step three, and then finally you get the software out, right? And then there is the other parts, which have become more and more of late, and most companies have moved on to this model, where you are constantly developing software, but you are actually not waiting for long periods of time to develop the software and give it to customers. Instead, you are developing smaller chunks of software, give it to customers, learn from how they are using it, and then constantly improve on it and give one more version and one more version and one more version and so on and so forth, right? So, and let me stop here and ask a very simple question, right? Like, I'm sure, how many of you are you? Let me ask this question first. In this call, how many people here use Instagram? Raise your hand. How many people use Instagram or WhatsApp? Raise your hand. Just three. I'm sure all of you use it. Okay, great. Okay. So, and how frequently do you think Instagram is updating their software? Not the app alone. So there are two parts to it, right? One is the app that you use on your phone, and the parts that they are updating on their server side, right? Where the server is running, giving all this content for you to serve and so on and so forth, right? How frequently do you think they are updating their server side? Once in a year, once in a few months? Who's saying type here? How many people think that it is done once a year? Raise your hand. How many people think that software for Instagram is updated like once a year or something like that? Raise your hand. Let me just see. How frequently do you think Instagram is updating the server side of the software, right? So Facebook or Meta is known for pushing software very, very frequently, more to the order of days or multiple times a day, uh, than like waiting for years before the software is actually, you know, perfect and so on. So what are they doing in these cases? They are actually doing incremental software changes, pushing it to production, seeing how users are using it, learning from it, and then making it better, and then keep pushing it and so on. So this is a typical model of incrementally developing software and pushing to production and so on. Okay. So, and that's the right model nowadays, where you are developing software and you are making sure that software is frequently updated such that customers can use their software or access the software in a much more faster way. Let's go to the next slide. Just see, why is it that my okay, the most common model that we all uh, are aware of is the model of software, which is called as the waterfall model, which is also one of the earliest models of how you deliver software. First is somebody sitting and providing requirements of how it needs to be, how the software needs to work, right? Followed by how it needs to be designed. And by design, you are essentially getting into, like, what are the various components, what is the responsibility of each of these components, how are they going to interact with one another, and so on. So that's what you mean by design. Third is implementation. Once you have the design of how the software needs to work, then you get into a mode of how you are going to actually write code for it, right? So you think about, okay, let there be a module now for login. Let there, in case of Instagram, for example, you need to have a module for user registering. You need to have a module for user logging in. You need to find a module for how the user is consuming content. How do you recommend a particular reel that a user needs to see? How do you provide an interaction such that you are tracking all the users' activity and so on? So there are so many modules which are distributed across various of these teams, and each of these teams is now writing code to achieve the functionality of this. And once that basic functionality of end-to-end is working, then you start testing it, right? You need to remember each of these teams have been working independently. So you need, while they may have tested their software, they first, when they write code, they should be testing it on whether, when it says that I am writing software for logging in, you need to validate that when you log in, it's actually logging in, and that it is, if you are having a password reset, there is functionality for how a user can reset their password or change their password and so on and so forth. And after that, they should be able to put together the end-to-end module and test it. So they have to test it. Now, once they have gone through this elaborate testing phase, they now are reasonably convinced that it's ready. They push it to deployment and they push it to production. And once they put it to production, you need to push it into the fact that now users are going to be starting using it. Now, no software is going to be perfect. There are going to be challenges or there are going to be issues. And not only that, you may have put in the software, but then you also realize that, what, there are additional things that is going to help my customers get value out of the software that I need to add, right? Like, for example, let's say you put Instagram as a way to just share videos, right? The next is you're going to say, what, I need to be able to personalize recommendations. I need to give recommendations, and only then I will be able to monetize or make money out of this platform. I need to be able to put ads in this platform, right? All of these are part of the fact that you are constantly improving the software in order to achieve your commercial goals as a business, right? So once you deploy the software, it's not just that of, okay, you're done. It's most of the time you are actually spending time maintaining the software and upgrading it, dealing with problems that are being reported, and so on, right? And let's take an example, right? Microsoft Office, right? The tools that you use for Word, PowerPoint, Excel, and so on, right? How old are they? They're almost going to be 40 years now, right? So you have been, and Microsoft did not sit idle saying that, hey, I've did this version 1.0 of the software where people could write documents and publish. Now they have got into mode of how can I make this better? How can I make this better? So they are constantly maintaining the software, and they are also constantly making it better and better and so on. So they are in a maintenance phase. You can say that it's in a maintenance phase, but you also have to remember that maintenance doesn't mean that it's just like you are done with it, right? It is about constant improvement. It is about constantly fixing issues that customers are reporting, and it's also about constantly understanding how customers are using the software and making the software better and so on. So let me pause here and see whether there are any questions. Any questions? Okay, the next, let me go to the next version of this delivery model, is this delivery model called the V model of delivery. What's the V model of delivery? V model of delivery is something where you typically use it in applications which are very critical, where tolerance to failure is something where it's very less. You cannot have too much failures in these systems, right? So in these types of systems where failure or bugs or issues are very, very critical, and that you want to minimize them or avoid them as much as possible, what you do is at every point of your software development lifecycle in the waterfall model, whether it's the requirements part, or it's the design part, or it's the architecture part, or it's the coding part, and so on and so forth. You are constantly validating and testing whether you have accomplished what you are supposed to have accomplished at that stage. So if there is a requirements that is done, you go and validate that these requirements are actually right. If there's a system design is done, before you proceed to the next step, you go and add this additional level of testing to make sure that your design is perfect, right? Or close to perfect, and so on and so forth. So every step of the way on the process, you keep on validating your module or your step deliverables, such that you are tightening the quality of the software at every step of the process. In the waterfall model, what you did was you tightened the quality, or you validated the quality towards the end before the deployment. In the V model, every step of the way you are constantly validating that this is meeting the standards for this stage of development as is. Okay. I will stop here. Any questions? Let's see whether there are any questions. Okay, let's move to the next part. In the incremental model of delivering software, what you are doing is that while for the overall end-to-end system, you kind of do some high-level planning and you kind of get some requirement and design, what you also do is you break these high-level design into smaller chunks such that there can be incrementally delivered. Many of these, like for example, the example that I was saying, right? Registering a user is a separate piece of software functionality. Login is a separate piece. recommending what video to see in case of Instagram is separate. And all of these can be done either in a sequential way or they can be done in an incremental way, in a parallel way, right? So you have given this basic module of how a user can log in and register, or you have a basic module for how, how, like, how you store the usernames, how you store the user passwords, and so on. And beyond that, you are building all these additional incremental functionality where this development process of for each of these individual functionalities can be done parallelly, such that the recommendation team is working on how to serve recommendations. They come up with the design for how to serve recommendations, they come up with the code for it, and they test it independently, and then they push it. So what is happening in this case is, you have this basic module that you have pushed, and then constantly there are all these parallel teams that are actually incrementally developing software and keep on pushing it. And this is the primary model with large teams today, right? Like for example, let's say you are looking at again Google search, for example, right? There is the core functionality of how do you actually index all the web pages. So that has been done. You put it there. Now, there is these additional things that can be added as additional functionality. How do you serve ads? How do you actually generate AI summaries of the search results, and so on? So that's a separate team that can go ahead and do this, right? So all of these teams are incrementally working on their functionality, and they are constantly improving that overall search experience, while the core module of how you are indexing all the web pages, and how you are storing the content, and how you are actually able to give the relevant search pages, that's still the same. But then all these additional things are constant incremental models of how software is being developed and how it is being put for users, such that users can use it in production. We take a pause here. Questions? Any questions? Let me see the chat window. Okay. Okay. Cool. Um, so the next is this concept called as spiral models, where spiral models is that of the fact that the entire scope of the project itself is not fully known. But what I do know is, I know that I can start with a smaller chunk of the project. And as I start developing the software and I develop this project, I will discover there is more functionality that need to be built, and then I expand the functionality that needs to be built, and so on. So this is the model called as a spiral model, where if it is really complicated that you can't specify how the whole system is going to behave, but you know that overall I need to achieve the target. This is my objective and alternative that I need to accomplish with this software. But then I'm just taking a small step, delivering it, understanding more, and then based on the small step that I'm taking, I'm going to expand the next step. I'm going to expand the scope of how this particular functionality is to be given. Like take an example of banking software, right? You don't know what types of things that a bank may need, right? There's just so many products, so many types of things. But I generally know there is just this concept of credit and debit to an account. So I'm going to develop software, just the ability to do credits from an account and the ability to do debits from an account. Okay. Now that I have done, I go give it to the bank and then say, okay, now that this is done, can we understand what more next? Oh, yeah, you have this concept of fixed deposits. You have this concept of recurring deposits. So let me try to bake that in, try to make it and expand the scope of what I've offered, give that to them, and then constantly keep developing these deliverables such that the scope of the software itself becomes larger and larger as we work through it. But at the same time, I also know that I am never done, right? Because the bank itself is going to be changing a lot of their business processes. There are constantly evolving and so on and so forth. So I'm constantly working with a smaller scope and then keep expanding the scope for building the software as this. Okay, next. Go to the next slide. I'll pause to see whether there are any questions on this before we move. Any other questions? Okay, let's move to the next one. In the 90s, what happened was this, there was a company called Rational, which was founded by a group of computer scientists who also part of this movement of programming called object-oriented programming, right? And they said that, look, when you are actually doing all these object-oriented programming and object-oriented design and those types of things, right? Probably we can come up with a process by which this can be defined on how we develop object-oriented design and object-oriented programming, right? So the process that they came up with is the process which is called as RUP, or also called as the rational unified process, right? And this is a process, it's similar to the incremental part as is, but it's just how they define it and how they take it is what it has changed, or how it has given structure to it, right? So what they are essentially saying is that, when you're developing software, um, going back to the bank example, for example, it's a large, complicated piece of software you're going to develop for banks, right? So why don't we actually just work with our banks and these large high-end risk projects where you take what this concept of use case development is, where you will go sit with the bank and understand how their business process itself works, right? How are they doing account credits? How are they doing debits and so on? Remember, you're not talking about what the software needs to do. You're not at all looking at it right now. All that you are looking at is how is the current business working? Can you model how the current business is, right? How the business workflow is. This is the concept of business modeling. So they come up with the concept of business modeling, where I'm modeling your business. I'm saying, okay, these are the actors. There is this customer, there is this teller, there is this clerk, there is the bank manager, and so on and so forth. These are all the actors, and these are the types of actions that they are doing in how this whole bank is working, right? So they are modeling the business. From the model of the business, then they try to come up with the requirements and the design to say, okay, now I know that this is the model. Now let me see what specific use case that I want to solve based on how this current business model works. The act of a customer coming and opening an account and depositing 1,000 rupees, right? That's a use case into their account so that it shows as a credit in their account, right? So that's the only thing I'm focusing on. Who are the actors here? What types of objects are involved here, what types of workflows are involved there. So they model it, and then from that they model it into objects and classes and things like that. And for each of these, they start writing code for how each of these objects are going to work, and then put together this piece of software where all of these objects and classes or instances of classes are interacting with one another to accomplish this act of the use case that they have identified, right? So, and once they get that, they give it to their customer, start them using it, and then they move on to identifying the next use case, the act of a customer getting a loan from that bank, right? Let me understand how that business model works. Let me model it, let me analyze it. Then I'll come up with an implementation of classes and objects. Then I'll put it in production. I'll see how it is working. I will test it, of course, and then I'll put it in production. I'll make it better. Then I move on to the next one. So this is the concept of the rational unified process, where you go into this identifying the business model, modeling the business. Then from that, you distill into the requirements, and then distill into the use that you want to develop and deliver software and so on. Let me pause here. Any questions? Seems like Sendamir Chelvi. Any questions? You've raised your hand. Okay, let's move to the next one. The next model, which is the typical model that is used nowadays, is this model of what is called as Scrum or Agile programming, right? What happens in this is you develop software in a fixed duration. You say, I'm going to have a sprint of 2 weeks. Typically, companies have sprints of 2 to 4 weeks. And within these sprint duration, what is it that I can do? I plan for the software that I can do within that 2 week duration. I take a couple of pieces of functionalities that need to be built. I plan for it. I design it. I develop it. I test it, and I push that piece of software within the specific duration that I am planned for as a sprint duration, right? What does this give you? It gives you the fact that the development process is extremely predictable. You know that all that I have is next 2 weeks. You know that in these 2 weeks, at the most, I am going to accomplish only these 3 or 4 items. It's possible that out of these 3 or 4 items, I'll accomplish only 2 items. That's fine. But I also know for sure that I'm taking only 3 items that I'm going to deliver in this duration. And I also know that I have to focus only on these 3 items. And if one of these items is not going within those 2 weeks, for whatever some surprises that come, then I know that it will automatically move to the next sprint duration or the sprint cycle as is. So in this model, which is what the predominant model of how the software industry works today, is that people are taking fixed duration. They are identifying fixed chunk of work or fixed pieces of software functionality or product that needs to be delivered. And whatever that they are delivering in that duration, they go review and they make sure that it is sent and so on. Okay, sent to customers, or customers are seeing the benefits of that software that is now. So this is the predominant model by which how most of the software companies are working today, where sprint, and it's the typical, this is also called associated with the agile concept of, companies want to be agile. They want to make sure that software is being delivered in a very structured, predictable way. And how better to bring in predictability? By showing that you have a fixed time only for delivering the software. There is no more, there is no less, but it's fixed time and you deliver software in that division. Okay? Questions? Let me see if there are any questions that people are having. Chat window. Okay, next. Next is this concept called extreme programming. Extreme programming is this concept of how you develop software as in iterations. It's again an iterative model, but then what you are doing is you are doing it as a pair, which is there are two developers who sit together, share the same screen, while one is writing code, the other one is looking at it, providing feedback. So both the people in that team are looking at the same piece of code, making sure that the coding standard is followed. And second is they are constantly looking for test-driven development, and they are constantly looking for how they integrate their software in a continuous way, such that it is integrated with other teams in a continuous way. And then once it is done, it is ready for acceptance testing with a larger team, and then it gets into deployment mode. So this is another mode where people talk about as extreme programming, where two people are looking at the same screen, sitting together and brainstorming together and writing code, right? Now, obviously, some people think that it decreases productivity because, instead of 10 people writing code, now what you have is 5 people, 5 terminals, but two people are sitting together and looking at the same piece of code, right? Is it going to improve productivity, not improve productivity? It's always a constant debate as this. But there are also instances where it has shown that it has improved productivity in the long run, right? Because you are developing better quality software, because somebody else is watching you when you are developing software, right? So when somebody is looking at your work as you are developing, as you're doing that work, obviously, in anything, you are going to do a better job at it, right? Because you just feel that somebody is looking at it. So I want to make sure that I am meeting the acceptable quality standards for a third person. So that's what happens in extreme programming. It was initially widely practiced. Nowadays, I don't see it much, probably because of these productivity concerns. Whether there is a productivity issue or not is subject to debate. But this is an example of what is called as extreme programming, pair programming, and so on. Any thoughts, any questions anyone wants to ask on this? Okay. I presume there are no questions. Let's move to the last model that we would uh, discuss, is this model called as Kanban. Kanban is a philosophy of comes from an inventory management philosophy called Kanban as just in time, which is that you are, when you are finished with work, you just take something else to work on, a smaller chunk of work to move it or make it better, right? Or to advance it. That's the whole principle of Kanban. So so you're not planning too much ahead. All that you're doing is, hey, there are 20 things to do. I'm taking one thing from a backlog of software to be built. I take one thing, I move it to to-do stage, I review it, and then I say, okay, let me go and work on it, plan for it. I move to an in-progress stage, and from there, I go develop software. And once I'm done with development of the software, I move it to testing phase. Once I am tested that piece of software, I move it to done. And sometimes I may be blocked on someone else. So I put it in a block state. And when I'm blocked on someone else, I go and revisit my backlog and take some other item from the backlog. So this is the model where there is a clear representation of all the project activities, and everyone knows what everyone else is working. Somebody knows, like, if you typically associate yourself, I don't know, say with a green post-it note in this, right? So you say, okay, I'm going to take this green task and move it to to-do, and from to-do I will move to implementation. From implementation slash in progress, I move to testing, and from in testing I'll move to done, and so on. So you're constantly working on something at the same time. Unlike the other models, you don't, you are focused on doing one thing, and you are focused on advancing that one task from one stage to another. And when you get blocked, you say you are blocked, and then you move to something else. And when someone else comes to unblock you, you go and move the blocked task, and you put it back into in progress or testing, and so on and so forth. So that's what you do. So this is the model of Kanban. Some teams work on it in a Kanban model. Some teams don't necessarily like this, and they stick to the Scrum model. But if you look at majority of the software companies across the world today, most of the software companies across the world are typically on the Scrum model of taking a fixed fixed sprint duration, deliver software for that duration, and then move from that to another. Okay, so I'll stop here, see whether there are questions. Because I'm sure you have a lot of questions. You have seen quite a few models today. So this is a summary of all the models that are generally known. And I'm going to take like a 3 or 4 minute break before spending the next 15 minutes, 20 minutes on case studies associated with this models. So we'll resume at, now it's 10:57. In 3 minutes, we'll resume. Okay, let's resume here at 3 minutes. Meanwhile, you guys can go take a bio break or drink water or coffee or whatever, and then be back by 11 o'clock. Okay, I'm back. Let's get started. So we have seen many of these models. Just to summarize, there was the waterfall and V model that we saw. And then there was these iterative and incremental models of things like Scrum, extreme programming, um, Kanban, and things like that. We also discussed that Scrum is probably one of the most prevalent models nowadays, where people take fixed duration and they work through software delivery during that fixed duration and make sure that there is small pieces of software that are incrementally delivered to customers that they can use and provide feedback on. Right now, let's take a case study of what type of models typically work in different types of cases. Right, an example is your Microsoft Office when it was provided as a desktop management product, right? Like your operating system that runs your Windows laptop and so on, right? There, what is required is that you don't update your operating system every uh, week or even every month, right? It happens, say, once in a few months. So what you have is the clear luxury of time of doing it at least once in a few months, right? Now, what is very important in these types of cases of software is that while you have the luxury of time, you also have to remember that they have to be very high in quality. You can't have an operating system product that is being shipped which is buggy or which has low quality and so on and so forth. So you want to typically clearly call out what quality standards you are, and you also want to clearly call out what types of um, requirements need to be done. So we typically follow the waterfall model in this type of software development process. So where software is typically developed once in a few months, you look at the requirements, you do the design, you do the implementation, you do an elaborate testing, you roll it out to a smaller set of customers, get feedback, and that's what we call alpha customers, beta customers, and so on. You first give it to a smaller set of customers where you know that you still have some bugs. You get their feedback. You improve based on their feedback. You give to a larger beta set of customers who are partners with you. And once they have provided all the feedback and you have incorporated the relevant ones, then you roll it out to all the customers. So that's why you hear about, hey, that's a beta product or that's an alpha product and so on and so forth, right? Which essentially tells that you're rolling software, but then it is smaller, incremental quality when you get it into alpha to beta mode. But then the waterfall mode itself, it's that it takes you a long time. You develop it, you ship it, and it's done in typical durations of months. Let's take the case of software like you are developing software which is for management of your mobile devices, right? And you're developing software where there's a lot of competitors, right? So when you have a lot of competitors in this type of space, what you want to be doing is developing software with a very high velocity. You want to get it to the market so fast, and you want to be faster than your competition and so on, right? And you also want to make sure that these types of software updates are aligned with your operating system updates on your mobile devices and so on and so forth, right? In these types of things where there is a high velocity, you want to be extremely nimble and agile. You go into that agile mode of the Scrum mode, where you are saying, I want to plan only 3 sprints or a 3-week sprint, or I want to plan for what I am going to deliver over the next 3 weeks, deliver it, push the code to all customers, and then move to the next one, and so on. So what you is giving you is this ability to be quickly responding to how the market conditions are, and at the same time change things based on quality, change things based on some new competitive feature you want to release or some innovation that you want to try and so on. So in these types of things, what happens is you want to be fast. At the same time, you don't want to compromise on quality. So you always work in these fixed duration in the Scrum model and so on, right? And sometimes what also happens is when you have initially you are in the Scrum model where you are doing it, oh, because you are competing in a startup mode. But once you have got a large set of customers, right, who are using your software for their daily usage, now you can't be giving them software quite frequently, because every new version of software that you're giving your customers means that they have to get used to the new features, the new user interfaces, the new ways in which these workflows are coming in, and so on and so forth. So you want to get into a mode which is a slightly hybrid mode, which is I don't want to be too fast in releasing it, but at the same time, internally, I will be doing these sprint modes of doing software every 3 weeks. But then to the external customers, I release it only once in 6 weeks or once in 2 months, and so on and so forth. So in a way, you are focusing the shift towards quality. You are focusing the shift towards growing the product for larger customers. You are making sure that your product is actually mission critical for your customers, and so on and so forth. So you are increasing the number of customers who are using it. When the more and more users start using your software, you don't want to push some new release which is going to break the functionality and break their workflows, because now it's critical for their business, right? So then you gradually move more into a mode of hybrid velocity, where there is internally you are trying to still work fast, but as far as the customers is concerned, you give them much better quality software in a slightly slower pace than how internally you are working. So this is another example of a hybrid model of software delivery. Now, there is also cases where, let's say you want to be uh, constantly releasing bug fixes for your software, right? Such that you cannot have uh, uh, have customers wait for a long time. An example would be Instagram, right? There is some bug that is there, there is some small improvement that is there, and so on and so forth, right? Or say bug fixes for your app that you have developed on your Apple App Store, which you see good adoption, and so on and so forth, right? And every day customers are providing feedback for your app, they are providing review comments for your app, and so on and so forth. So in these types of models, you can probably go the Kanban model, where there is always a backlog that is keep constantly coming in, right? There is always feedback of customers saying, hey, can you build this, can you build that, can you put this feature, can you put this, and so on and so forth. And you are looking at all of these, and then your software team is saying, okay, hey, that seems like a good idea, let me go take it, implement it, and give it to customers, right? So they're constantly developing. So in these types of models, what they are doing is in a Kanban model, and they are daily releasing software for bug fixes, like in Instagram or Gmail or Google. There is constantly update of the software that's happening. But at the same time, given there are millions of users that are using it, you want to be developing the software and deploying it, but at the same time, it should not cost any downtime for the software itself, right? Remember, there are customers who are using your software 24/7. Imagine you are part of the Instagram development team, or you are part of the Gmail development team, right? While you are constantly improving and pushing code, pushing bug fixes every day, or pushing new code every day, you don't want it to cause any downtime for people using Gmail or Instagram, right? So there is a strict adherence to quality also required, but at the same time, you are constantly improving, innovating, and so on. And typically, this happens in the B2C types of software. Okay, we come to the summary of all these, right? The main thing that you have to remember is that when you develop software and you are actually giving it to customers to use, and it's useful software that customers are using, there is no time where you are saying that I am done. I am done developing the software. It is what is guaranteed is that there is always change that needs to be done to the software, because customers are constantly changing. There are customers who are demanding how things need to be done in a different way. There are bugs. So what you can be guaranteed is that change is the only constant when you start developing software, right? And nothing is, oh, that project is something that is done with, there is absolutely nothing there, right? Because most of the time you are, what people call as maintenance of software is what people are actually working on, which is improving the software. Most if you look at it, Google search, right? Google search itself has been around for over 25, 26 years, right? Does that mean that there is no innovation there? Is it in maintenance mode? Yes, it is in maintenance mode, but then there is constant innovation. There is constant upgrade of how search is happening, or a constant upgrade of how Gmail is happening, and so on and so forth, right? So what is very important is the realization that software is always changing. Software, and what is very important is the fact that you need to use the right model to deliver the software with good velocity and with good quality. And there are multiple models and multiple processes by which you can develop software. And the best way for you to develop software is, first, make sure that you have a good architecture. Second is you can adapt to change on this. Okay, that brings me to the end of this session. Let me see if there are any questions. Any questions? I'm going to ask a question, so I want people to type their responses in this answer. Let's take an example of Windows operating system. Um, what is the typical software development model by which operating systems like Windows will be upgraded? Can can you guys type the responses in the chat window? Let me see how many are typing the responses in the chat window. Are you guys able to hear me? Any questions? Any questions from anyone on the line or on the call? Okay, I presume there are no more questions. If there is any questions, you are always welcome to reach out to us. Let us know if there's anything that we can help address on this. Again, the summary is that in software delivery models, change is the only constant, and you need to make sure that you are choosing the right model that suits you, your business, and your customers. Thank you very much. Bye.